How can we enable peer learning in online settings? This is Mohammed. I'm a PhD student at Big Data Analytics Lab at NJIT. Social sites such as Reddit, Facebook, and Quora promote peer learning, which involves groups of people working together to solve a problem, complete a task, or create a product. This has the potential to bring out the unique strength of each individual while improving the work through teamwork and collaboration. In this work, our goal is to propose a principled abstraction to the peer learning problem. Particularly, we want to investigate how to form group of groups to promote peer learning. We consider two concepts. One is learning potential and the other is affinity or collaborativeness. Learning potential, which is to understand how one learns in peer learning, has two natural variants that we capture. LPA is a case where every individual in the group learns from all other individuals that are higher skilled. LPD is where the weakest member learns from the most skilled individual in the group. Similarly, we consider two variants of affinity. Affinity all models collaborativeness of every pair of individuals in the group, and affinity center reflects the affinity between the students and the teacher or moderator. We want to create a number of equal-sized groups such that both aggregated learning potential and affinity are maximized. This leads us to 4 different problem variations, which are multi-objective optimization problems with 2 different criteria. Our first contribution is this formalism. Turns out all the 4 different combinations of learning potential and affinity are NP-hard. That means they are not polynomial time solvable. Our second contribution is to come up with a suite of approximation algorithms where each has provable constant approximation factors and efficient running time. Our experimental contribution is twofold. We deploy fact-checking and learning application with real workers from Amazon Mechanical Turk to demonstrate that affinity improves peer learning with statistical significance. And our synthetic data experiments are comprehensive and demonstrate the scalability and effectiveness of our algorithms. Based on our simulation results, our algorithms can handle millions of workers and hundreds of groups and achieve 1.3 approximation factor empirically and run only in few seconds. To summarize, our paper is the first to formalize peer learning and affinity in online platforms. We propose principal models, effective algorithms, and extensive experimental results. Our future work focuses on how we model peer learning in dynamic groups where members can change groups over time. I would like to conclude by introducing our team. Dong and I are PhD students at BDAL, Sihem is our fantastic collaborator, and Senjuti is our PhD advisor. Thank you very much for your time.